Yes, I will try to present some of experience we had with in the forecasting of summer convective rainfall and big storm, two of the uh, triggering factor for us for landslide in Norway. My name is Graziella Devoli. I work at Norwegian Water Resource and Energy Directorate. And just some numbers. We have been operational since 2013. We have a national organized early warning system, but which is managed by NVE, but is we send a regional forecast for a group of municipality of a group of county. The organization of the landslide early warning system is doing strongly with the Norwegian Meteorological Institute and with the National Public Road Administration and the National Railway Authority. These are the numbers of number of warning that we have sent since 2013. A lot of yellow colors, which is our first level. We have orange, and we send only 2 red level, which was in 2013 and in this year in January. Another statistic is the number of landslide warning in a month. And this is because I say in other occasion that we send the warning and we have landslide problem all year around. So we don't have really the time to sit and do research properly, like maybe in other countries where they have 6 months rainfall and 6 months dry season. So as you can see, May is the month where we have a lot of landslide warning. This is one of the reasons why all the time we have to organize something. I say, no, please don't organize nothing in May. But also December is, we send a lot of warning, and June. We see the landslide triggering factor we have divided in 4 types. We have intense rainfall that trigger landslide, intense rainfall combined with snow melt, summer convective rainfall, and snow melt. And in the first 2 situations, we have we have 2 types of warning. One is issued by the Meteorological Institute only for rainfall, and if there is the need, we also issue a landslide early warning. For summer convective rainfall, we have decided since 2016 to organize combine warning together with the Meteorological Institute just to avoid because these cases are very difficult to predict, and so we have a combined warning. But we can have also the case where we have only snow melt, there is no rainfall, but warm many days with the warm temperature. And so in this case, it's only NVE that is issue a landslide warning. In this case, I will try to present 2 cases, one of big storm. We have essentially what we call big storm are mainly in autumn and winter. I will present on the winter storm, which affected mainly the western part of Norway between November and February. I would say relatively easy to forecast because we can have in advance, at least 3-5 days in advance. And we have summer convective rainfall, which are, here I put in this red color is the typical area where we have rainfall, summer convective rainfall that trigger landslide, that have triggered landslides so far. And this type of weather condition is mainly from June to August, but also in some years it already starts in May until October. And these are more difficult to forecast. Let's say if we are lucky, some hour in advance, yeah, in some cases. So the first case is the extreme weather Gida. This arrived in the country in the 12 and 13 of January in 2022. This is a typical winter storm that arrived in the country where there is already some snow. It brings not only rainfall, but also a lot of warm temperature and strong wind that create additional snow melting. These usually are, as you can say, a low pressure that arrive from the southwestern part of the Atlantic. Usually they are extreme events that trigger a lot of landslide, all kind of landslide, debris avalanche, debris flow, slash flow, but also snow avalanche and flood. And they are also associated with what we call atmospheric river that pump a lot of rainfall in the western part. I say that they are relatively easy to predict, because when we look at the day in advance, we can see that the prognosis that we receive every day are quite stable. So you can see the same intensity, the same area, the spatial distribution and the temporal distribution of the prediction of the different model, both the European model and the Nordic model that we use. They are quite stable during the different modeling. And so we are, in this case, we saw many days in advance already. Here I couldn't put all the day, but already the 9th, we could see that for the 12th of January, sorry, there will be a lot of rainfall and above 80 millimeter. And this prognosis was, we could see again and again. Also, when we look at our landslide threshold, we could see that already on the 6th of January, we had some moderate and considerable danger in the western part of Norway. This prognosis was also visible and even worse while we were approaching the day of the event. So for the 9th of January, we could see that for the 12th and for the 13th, we had a very red that there have been many years that we haven't seen the red level in our landslide threshold. And so it was a kind of easy situation to predict. So it was already sent for the 10th of January rainfall warning, and also a landslide and flood early warning in orange for this area. And this was the situation on the 12th of January. So we have red and orange mainly for flood, landslide, snow avalanche. And the event got the name Gida when they exceed some specific value. As I said, this was easy to communicate because since you send already a red level, got a lot of media attention. Also, it was the first red event after so many years, and I think the previous, in terms of flood, was in 2017. So there were many closed roads in advance. So all stakeholders, they take us very seriously, and they close road. Here also we can see the railway that it was closed, and I will focus on this area. Also, we focus on giving information to our regional office. And this is, you can see a series of landslides that occur in the area. And probably the most serious damage was this in the railway Meråker, which was closed in advance. Fortunately, yes, and this we can see afterwards our landslide threshold out its work, the prognosis and the observed one, and we can see that also in the area where this landslide occur, we had the red level and more than 80 millimeter of rain. We got many positive feedback from stakeholders. They liked the fact that we warn in advance. On the contrary, we have this example of summer convective rainfall. That arrived almost in the same area where the railway is located on the 2nd and 3rd of June. These are a bit more difficult to predict because when we look, for example, at the 31st of May, we could not see any rainfall in this area. Is possible? No, I cannot. Here in this area, we could not see any rainfall. There was something for the day after, and also on the 1st of June, there is very little rainfall in this area. But on the 2nd of June, which is the same day, we could already see some typical circle monster-like pattern, which are mainly due to summer convective rainfall, a lot of them in Sweden. But we could see some here in this part, and this was the reason why afterwards it was sent a warning. This is the example of warning that we have together with the Meteorological Institute. They send the warning, but we have a common sentence here in the consequence that we inform that there will be also landslide and probably flood. And here are the example of landslide, many shallow landslide that occur again in the same railway sector. This one is very important, and there were more than one in this area, and this is the main railway sector that was affected. One of the problems is when we look at our landslide threshold, we see that in the prognosis, there were some pixels of moderate and considerable danger, but the rest was green, and it was not easy to send a specific warning for that. And this is why the reason that it's better to send just one kind of meteorological warning. And when we look at the observer, we actually we have an entire thing was green, and the meteorological station, they didn't measure the rainfall that was in this area. And that's it. Thank you very much.